बिस्मिल्लाहिर्रहमानिर्रहीम। रब्बी ज़िदनी इल्मा, ऐ मेरे रब मेरे इल्म में इजाफ़ा फरमा, आमीन। अस्सलाम वालेकुम class, I am your physics teacher Iram. We are studying chapter number 12, geometrical optics. We have completed all the topics. Now we have to start the exercise. Today we have to solve the numericals. You have to remember all of the formulas given in the chapter so that you can easily solve the numericals. Let's see what were the formulas that we have studied in this chapter. First was spherical mirror formula and lens equation. Both are same. It was 1 by f equals to 1 by p plus 1 by q, where f represents the focal length of mirrors and lenses, p represents the distance of object from the center, optical center of the lens or the pole of the mirrors, and q is the distance of image from optical center of the lens or from the pole of the mirror. Next are the sign conventions for mirrors. You have to take special care of the sign conventions so that you can solve the numericals correctly. You have to keep in your mind that the focal length of concave mirror is taken as positive and the focal length of convex mirror is taken as negative. Similarly, the object distance p is positive for real object and negative for virtual object, and the image distance q is positive for real image and negative for virtual image. These are the sign conventions for mirrors. The sign conventions for lenses: the focal length of converging lens is positive and diverging lens is negative. And object location p, it is positive when object is in front of the lens and it is negative when it is at back of the lens. Image location q, image is in the back of the lens and it is negative if image is in front of the lens. So these are the sign conventions for lenses. These are really very important that you have to remember. You must remember that where you have to use negative sign and where you have to use positive sign, and for which lens or which mirror have positive focal length or negative focal length, and so on. Next is the formula for magnification. It is height of image divided by height of object, and it is also equal to q divided by p, where q is the image distance and p is the object distance. One more formula we have studied at the start of the chapter was focal length is half of the radius of curvature. All of these formulas are used in the solutions, so you have to remember these. Let's start with 12.1. Look at the statement. An object 10 cm in front of the convex mirror forms an image 5 cm behind the mirror. What is the focal length of mirror? Now, two things are given. First of all, from the statement you have to identify which quantities are given and which are required. Let's see. It is given that an object 10 cm in front of convex mirror. So the mirror is convex and object in front of the convex mirror means it is the object location, which is P. Forms an image 5 cm behind the mirror, which is 5 cm is the image is 5 cm behind the mirror, so it is Q, the image location. What is the focal length of the mirror? So we have to find out the focal length of mirror. Now this is convex mirror. Keep in your mind the sign conventions for mirrors, that F is positive for concave mirror and F is negative for convex mirror. Let's start the data, then I will tell you what you have to use there. Here is the solution. First of all, you have to write the data. P is 10 centimeters, Q is 5 centimeters. Why we have written minus 5 here? Here you can see that I have written minus 5 centimeter, because you know that as it is a convex mirror, it is like this. The outer side is reflecting and the inner side is painted. So the object is located somewhere here at the distance of 10 centimeter from the mirror, and the image is located behind the mirror. Means as you can also recall that while discussing the ray diagrams or the reflection through convex mirror, I have told you that it is a diverging mirror. It will scatter all the light rays incident on it, and they are focused behind the mirror on this point on the principal focus. That's why we will take the focal length as negative, and Q also will be negative here. You have to take F is required, so we have to take Q as negative in the data because it is present behind the mirror. And in case of mirrors, you know that we can see the reflection in the mirror, so the uh, what we can say image is present on the same side to that of the object. If the object lies on the same if the image lies on the same side of the object, then it will be taken as positive, and if it is present behind the mirror, it will be taken as negative. So is the case with this convex mirror. So let's start the solution. Q is -5. It's remember that it is not given in the statement, it is just you have just given with Q equals to 5 centimeter. You have to write this minus sign by yourself. If you do not write this, then your solution will be wrong. Solution, first of all you have to write the formula. 1 by f equals to 1 by p plus 1 by q. Let's put the values. 1 by f equals to 1 by 10 plus 1 by minus 5. This plus and minus makes minus here. 1 by 10 minus 1 by 5 is here. Here you have to take the LCM. I think you can easily take the LCM here. You can easily solve this further. So it will be minus 1 by 10. Here you can see 1 by f is equal to minus 1 by 10, but only f is required. So how you can take f? You have to reverse the fraction on both sides. So it will be f equals to minus 10 centimeter. One method is that you have to invert both the fractions, or you can also cross multiply this so that you can get f equals to minus 10 centimeters. Here you can see the focal length also comes out to be negative, which shows that the convex mirror, the focal length of convex mirror is negative. That was 12.1. 12.2 is an object 30 centimeter tall is located 10.5 centimeter from a concave mirror with the focal length 16 centimeters. Yes. Where is the image located? How high is it? Now, first thing is an object 30 centimeter tall. From the word tall, you can easily guess that 30 centimeter is the height of object represented by h naught. Is located 10.5 centimeter means it is the object location represented by P from a concave mirror. Now, a concave mirror is given with the focal length 16 centimeter. As you know that the focal length of concave mirror is always positive, so you don't have to write negative sign with it. Where is the image located? You have to find out Q. How high is it? You have to find out height of image, HI. First of all, you have to write the data. Height of object is given 30 centimeters. P is 10.5 centimeters. It is the distance of object from the mirror. Focal length of concave mirror is given 16, and you have you don't have to write negative sign here because focal length of concave mirror is positive. Q is required and height of image is required. Same formula, 1 by f equals to 1 by p plus 1 by q. Here you can see 1 by f equals to 1 by p plus 1 by q. Here I have put the values 1 by 16. Now what I have done, I have just taken 1 by p on the other side of equality so that it will become negative. Here is the negative sign just because it is taken to the left hand side, and 1 by q is here because we have to find out q. We have to separate 1 by q first. Again, taking the LCM here, you will come to minus 5.5 divided by 168. So 1 by q is, now you can see it is minus 5.5 divided by 168, so the value will be minus 0.0327 equals to 1 by q. And when you when you cross multiply these two sides, you will get q equals to minus 30.54 centimeters. This negative sign shows that in this case the image is virtual and forms behind the mirror. Whenever q is negative, it means it is formed behind the mirror. So next thing is how high is it. For the height of image, we have to use the formula for magnification. It is hi divided by h naught equals to q by p. Just rearrange it. For hi, h naught will be taken on the other side and it will get multiplied here. Hi equals to, putting the values, you will get 87.26 centimeters. Here you don't have to write minus sign with q, because you have to just finding out the height. So it will be 87.26 centimeters. Here you can compare the heights of object and image. Height of object is 30 centimeters, whereas height of image is 87.26. It means it is magnified. It is very much larger in size with that of object, and it is virtual, forms behind the mirror. 12.3. An object and its image in a concave mirror are of same height, yet inverted. When the object is 20 cm from the mirror, what is the focal length of mirror? Here it is given that hi and h naught are equal. Object is 20 cm from mirror, its p, f is required. Here you can see the data. Hi equals to h naught, p is given 20 centimeters. Here q is not given, which is compulsory to find out the f. So first of all we have to find out q from the formula of magnification. Hi over h naught equals to q by p. Here hi and h naught are equal, so by putting hi equals to h naught, they will be cancelled. Here you will be left with 1 equals to q by p, so q will be equal to p in this case. By using the mirror formula, 1 by f equals to 1 by p plus 1 by q, by putting q equals to p, here by taking the LCM you will get 2 by p. By cross multiplication you will get p equals to 2f. Put the value for p, which is 20. 20 by 2 will be 10 centimeters. Here you will get the focal length of concave mirror as 10 centimeters. As you can see, focal length is concave mirror is used, so its focal length comes out to be positive. 12.4. Find the focal length of a mirror that forms an image 5.66 cm behind mirror of an object placed at 34.4 cm in front of the mirror. Is the mirror concave or convex? First of all, you have to find out the focal length of a mirror which forms an image. 5.6 is, this is q. Object placed at 34.4, this is p, in front of the mirror. So you have to find out, I think you can guess which mirror it will be from the statement, as it is given that it forms an image behind the mirror. Yes, keep on guessing while solving the numerical. Here is the data. F is required, q is given 5.66 centimeter behind the mirror, so you have to write minus 5.66. It is very important to remember all the sign conventions, otherwise you cannot solve these numericals correctly. Q equals to minus 5.66 centimeter. P is given 34.4 by using spherical mirror formula, putting the values. By taking the LCM you will come to the step 1 by f equals to minus 0.1476. Here 1 by f is there. Most of the students get confused here that this is the value of f. It is not the value of f, it is 1 by f. You have to find out f by cross multiplying here. You will get f on this side. F will be equal to 1 by 0.1476 and negative sign will be there. So f is minus 6.77 centimeter. Yes, so your guess was right. The mirror will be convex because its focal length comes out to be negative. 12.5. An image of a statue appears to be 11.5 centimeter behind convex mirror with focal length 13.5 centimeter. Find the distance from statue to the mirror. Here again a convex mirror is here. Image is behind convex mirror. Yes, QA will be negative. Focal length will also be negative because it is a convex mirror, and you have to find the distance. P is required, F and Q are given. Here you can see F is 13.5 given in the statement. You have to write negative sign by yourself. Q is 11.5 centimeter. You have to write negative sign yourself. Putting the spherical mirror formula, 1 by f equals 1 by p plus 1 by q. Taking 1 by q on this side, you will have a negative sign with 1 by q. Putting the values, you will get 1 by minus 13.5 because f is minus 13.5. Minus sign, this sign is here, and value of q is also negative, which is minus 11.5 equals to 1 by p. Now these two negative signs will make a positive sign here. By solving this, you will get P equals to 77.62 centimeters. So one thing more that you can see that all the distances are taken in centimeters and we are not converting them in meters because these mirrors and objects are these mirrors are used to make the image by locating the object in front of the mirrors in centimeters at some not at the larger distances but at the short distances. So the centimeter is okay. In all these numericals we have to take all the distances in centimeters, and as all the distances are in centimeters, so no need to convert them. If any one of them is in meters or in any other unit of length, then you have to convert that and you have to get you get all the distances in same unit, then you have to solve it. 12.6. An image is produced by a concave mirror of focal length 8.7 centimeter. The object is 13.2 centimeter tall and at a distance 19.3 centimeter from mirror. Find location and height of image. Find height of image produced if object is twice as far from mirror. Yes, it is a lengthy one. An image is produced by concave mirror. Concave mirror is given, so its focal length will be positive. F is 8.7. Object is 13.2 centimeter tall. This is H naught. And distance P is 19.3. Location and height is required for this situation. And find the height of image produced if object is twice as far from the mirror. First, the distance of object from the mirror was 19.3. You have to find out the location and height for that case, and then you have to take the object at the double distance from 19.3, means you have to multiply 19.3 by 2, you will get twice the distance. Then you have to find out that what should be the height of image in that case, because you know that the height of the size of image depends upon the location of object in front of the mirrors. Here is a solution. focal length is 8.7, h naught is 13.2 and p is 19.3. First requirement is q and hi for this case, and second is requirement is the height of image for the case if the object distance is doubled. So you have to write p dash just to differentiate it from the first distance of the object. So you should write it as p bar or p dash, which will be equal to 2p, and it is actually 38.6. Solution for the first case, 1 by f equals to 1 by p plus 1 by q. You have to find out q, so you have to separate 1 by q first. Take 1 by p on the other side, it will be negative 1 by f minus 1 by p. Putting the values by solving, you will get q as 15.84 centimeters. First requirement, this is done. Now hi is required, hi by h naught by the formula of magnification, q by p. Take h naught on the other side, it will be multiplied. Putting the values, you will get the height of image as 10.83. Now you can compare the heights of object and image. This is 13.2 and this is 10.83. In this case, the size of image is reduced from the object. Now the second case, in which we have doubled the distance of object. So in that case, the image distance will also be changed as well as the height of image. So first of all, we have to find out q, the location of image, because it also depends upon the distance of object as it is doubled. So we have to see what should be the change in q. 1 by f equals to 1 by p dash plus 1 by q. So by taking 1 by q on the other side, you can also use q dash here. Yes, because it will also be changed, q dash, so that we can say that it is different from the first one. 1 by q dash will be equal to 1 by f minus 1 by p dash. Putting the values and solving will give you q dash equals to 11.231. Now it is different from the first, 11.231. Yes. Now you have to find out the height. Take h naught on the other side, it will be multiplied by putting the values, new values of q dash and p dash. You will get 3.84 centimeters. Now you can again compare the values of you can compare the heights. H naught was 13.2 centimeter tall. In first case, it is reduced to 10.83. Now it is reduced to 3.84, means it is again reduced. You have taken the object to the double the distance, and here the height of image is reduced again. So we can see that the size and location of the image depends upon the location of the object in front of the mirror. 12.7. Nabila uses concave mirror with radius of curvature 38 centimeters. Find focal length. Concave mirror is here. Yes. Nabila is located at 50 centimeter from mirror. What is the object in this case? Nabila is the object. So 50 centimeter is the object distance P. Where will her image appear? This is actually Q, which is required. Will the image upright or inverted? You have to tell the nature of image as well. Solution. Radius of curvature represented by capital R is 38 centimeters. F is required. P is 50 centimeters. Q is required. Nature of image is also required. Spherical mirror formula, 1 by F equals to 1 by P plus 1 by Q. As I have told you the relationship between focal length and radius of curvature is that focal length is half of the radius of curvature. To putting the values, 38 by 2 will give you the focal length 19 centimeters. Now the mirror is concave, so whether you have to write negative sign here or not, yes, you don't have to write negative sign because the focal length of concave mirror is always positive. Now you have to find out the location of image, so you have to separate 1 by q. 1 by p taken on the other side will be negative 1 by f minus 1 by p. By taking the LCM and solution gives you q equals to 30.64 centimeters. In this case, the image is upright because it is positive, and here you can see that P is 50 centimeters and F is 19 centimeters. It means the object is located outside the focal length, so the image will be upright. 12.8. An object 4 cm high is placed at a distance of 12 cm. Convex lens of focal length 8 cm. An object 4 cm high means height of object is 4 cm. Distance from convex lens. Now here we have started the numericals with lenses. Now you have to remember the sign conventions for lenses. Here is a convex lens. It's the distance of object is P is 12 cm, F is 8 cm. Position and size of image is required. Also state its nature. Height of object is 4 centimeters. P is 12 centimeter, F is 8 centimeter. Now here convex lens is used, so its focal length will be positive. Q is required, height of image is required, nature is required, solution. Now here is the lens equation. 1 by F equals to 1 by P plus 1 by Q. You have to find out Q, so you have to take 1 by Q on one side. 1 by P will be taken to the other side. By solution, by taking the LCM and solution gives you Q equals to 24 centimeter. For the height, you have to use the formula for magnification. Hi by h naught will be equal to Q by P. H naught taken on the other side will get multiplied here. Solution gives you height of image as 8 centimeters. So by comparing H naught and Hi, 4 and 8, it means height of image is more than height of object. We can say it is magnified. So as the lens is convex, so it will make real and inverted images, and from this comparison we can see that magnified image is there. So the nature of image will be real, inverted and magnified. 12.9. An object 10 cm high is placed at distance of 20 cm from a concave lens of focal length 15 cm. Height of object H naught is 10 cm, P is 20 cm, focal length 15 cm, but here is concave lens, so you have to write negative sign because the focal length of concave lens is negative. Calculate position and size of image. Position means Q and size Hi is required. H naught is given. P, F, Q and Hi are required. Lens equation, P taken on the other side. F will be negative minus 15 and minus 1 by 20, taking the LCM, negative sign. Q equals to minus 8.57 centimeters. For height, again the formula for magnification, H naught taken on the other side. Solution gives the height of image as 4.28. Compare the heights of object and the image 10 and 4. It means the size of image is reduced as compared to the size of object. So we can say that the image is diminished. The lesser in size image is called diminished image. Concave lens is there, so it will form virtual and erect images. Hence we can write the nature of image as virtual, erect and diminished image is formed. 12.10. A convex lens of focal length 6 cm is to be used to form a virtual image 3 times the size of object. Where must the lens be placed? A convex lens means focal length will be positive, yes, and 6 cm is the given, but the here the convex lens is used to form a virtual image 3 times the size of object. Yes, the image will be 3 times high than that of the object. Where must the lens be placed means you have to find out P. It means from where must the lens be, yes, be placed in with respect to the object. So it is P which is required. You can see F is 6 cm and HI, height of image, will be 3 times the height of object. So we have to write HI equals to 3H naught. P is required. So let's start with the formula for magnification. HI by H naught equals to Q by P. Putting HI equals to 3H naught by H naught. Cancellation gives you 3 and cross multiplication gives you 3P equals to Q. As virtual image is formed, it is given in the statement, you have to write negative sign with the Q. Don't forget to write it, otherwise the answer will be wrong. 1 by F equals 1 by P plus 1 by Q. Here Q will be minus 3P. Taking the LCM and solving it, and in the end cross multiplication gives you 3P equals to 2 multiply 6. The distance of object must be 4 centimeter. Means focal length is 6 centimeter, P is 4 centimeter. Means you have to take the object within the focal length of convex lens. In this case, remember that in this case the lens will behave as a magnifying glass, and in that case the virtual image will be formed. I think you remember that. If you have practiced that was the case when the object was taken inside the focal length, then what was happening there, these were taken here and Q will be 3 times P. A magnified and virtual image is formed on the same side of the object. 12.11. A ray of light from air is incident on a liquid at angle of incidence 35 degrees. Calculate angle of refraction if refractive index of liquid is 1.25. Also find critical angle between liquid air interface. This is the case with Snell's law. The light ray is incident on a liquid at an angle of incidence. You can, what I have done, yes, data is here. Angle of incidence is 35 degrees. Refraction is required. Angle of refraction is required, and for liquid is NL. L represents the liquid is 1.25. You know that the refractive index of air is 1. Critical angle is also required. N equals to sin I by sin R. This is the Snell's law. Yes. Sin R equals to by rearranging this formula for r. Sin r will be sin I divided by n. So sin 35 divided by 1.25, solution gives you here sin r equals to 0.458, and you have to find out just the angle of refraction. So you have to take sine. On the other side it will become sine inverse of this quantity, and it will give you 27.13 degrees angle of refraction. I want to draw a diagram for you. If here is a liquid in the container, here the light ray is incident from air inside the liquid. Here is the angle of incidence, which is 35 degrees, and as you know that the liquid is a denser medium as compared to air, so the light ray must bend towards the normal. It is also clear from the angle of refraction, which comes out to be 27.13, lesser than 35. It means whenever the light ray enters from rare to denser medium, it bends towards the normal, so in that case angle of refraction is less than angle of incidence, which is proved by this numerical also. In second case, you have to in second part we have to find out the angle, critical angle. For critical angle, here as you can see that in case of total internal reflection we have discussed critical angle, but in that case the light ray was incident from a denser medium like the glass, and it was entering in the rare medium. That was the condition for total internal reflection. But here the light ray, here we have the case when the light ray is entering from air into the liquid. It means for this case here is the angle of incidence, and the light ray will bend like this by making the angle of refraction 90 degrees. In this case the angle of incidence will be the critical angle. So what will happen, we have to reverse this fraction here. Actually it was in just like in the Snell's law, we have just seen that n equals to sin I by sin r is there, but in that case, and for I equals to c and r equals to 90 degree, what was the condition, that the light ray must be incident from denser to rare medium, but here the case is reversed. The light ray is incident from rare to denser medium, so you have to reverse this side. 1 by n will be equal to sin c by sin 90, where sin I in place of sin I have written sin c. Why? Because for the angle of incidence to be critical angle, the angle of refraction will be 90 degree. That's why I have written 90 degree here in place of sin r. Now putting the values 1 by 1.25, sin c will be there because you have to find out c, and sin 90 is 1. Cross multiplication gives us c equals to sin inverse of 1 by 1.25. By solution, by you can easily solve it from calculator, it will come out to be 53.13 degrees. So the critical angle in this case is 53.13 degrees. Last numerical is the power of convex lens is 5 diopters. D is for diopter, which is the unit for power of lens. Convex lens is there. At what distance the object should be placed from lens so that it's real and 2 times larger image is formed? You can see that power is given, the focal length is not given. It means you have to use the power of lens to find the focal length, and you must remember the relationship between focal length and power of lens. I think you remember. Yes, it is. Just see the data first. It is Power is 5D. Now this power will be represented by capital P, or you can write the power uh, full in full spellings. So to differentiate, this is small p distance is required to make the image which is double the height of object. By using magnification formula hi by h naught, putting hi equals to 2h naught, you will be having q equals to 2p. Now this is the relationship between power of lens and focal length of the lens. If the focal length is given in meters, then it will be, the power of lens will be 1 by f, 1 by focal length in meters. So as it is in diopters, so the focal length here is in meters. You have to take the focal length in meters here. So by rearranging this equation, f will be equal to 1 by p. Putting the value of p, which is 5, you will have 1 by 5 equals to 0.2 meters. Now as you know that the distances will be in centimeters, p and q, short distances will be there, so you have to convert this meter into centimeter first. Just multiply it with 100, you will get 20 centimeters using the lens equation. 1 by f equals 1 by p plus 1 by q. P is required, so take it on the other side. 1 by q will be taken on the other side. 1 by f minus 1 by q will be there, putting the values. Now q is replaced by 2p because of this equation. Now you have to take the LCM of p and 2p. You will be having 1 by 20 equals to 3 by 2p, cross multiply it here. 2p will be equal to 60 and you will be left with p equals to 30 centimeters. Here if you place an object in front of a convex lens at 30 centimeter, you will get an image 2 times higher to that of the object. So that was all about our numericals. They were confusing and somewhat difficult, that's why I have solved them for you. So you have to take you have to carefully practice them as much as you can, so that you can remember the sign conventions while solving the numericals, which are very important. Here is your homework. A question is here, a numerical is here. You have to solve this numerical and send the solution in the group as your homework. An object is 14 centimeter in front of a convex mirror. Image is 5.8 centimeter behind the mirror. What will be the focal length of mirror? You have to find out the focal length. Solve all the numericals in your neat notebooks and practice them on rough registers as well. In case of any problem, you can ask anything anytime. Thank you.